Again, notice that the linemen are wearing very thick gloves that are rated and tested at 15,000 volts. This household glove is not going to protect you. There's a hot dog inside of it. So he's basically is going to touch this fence that's going to have 7,000 volts on it. He's going to touch it with that rubber glove. Now, Pat would not touch it without that stick and those gloves in his hand because he would die. So he's going to maintain his clearance. Trailer hot? If you got a camera, this is a good picture right here. Go slow.
Wow.
Now that's what happens when you touch a fence. Now you would become electrocuted. That 7,000 volts going to go through your body. The reason it's not going through Pat's body is because of that stick and those gloves that he's wearing. That household glove didn't help anything. So even though it's made out of rubber, it's going to maybe protect you from dishpan hands. That's about it.
Can I get a roll for that?
A what?
Roll?
We will give you the hot dog if you would like. Next, we'd like to demonstrate a fireman's boot. The fireman's boot is going to be walking on an energized power line. Although the boot is made out of rubber, there's not enough protection against our primary voltage. Our gloves are tested before every use in clean storage. This boot has holes in it, oil stains on it, making it very unsafe to wear on or near energized power lines. In this next demonstration, we're going to act right there in that box. There's dirt in there. We're going to run 7,000 volts through that dirt. So basically we're going to demonstrate is somebody walking with those boots on 7,000 volts. We're going to show you how it does not protect you. Trailer hot? Again, this is a good picture right here. A little slower.
Ooh.
That's like lightning. 7,000 volts trying to track to ground. If you notice, Glenn, all he's doing is isolating. He's opening up, which is like a light switch basically to us. When he opens those doors, he kills power and is safety for us during the demonstration. With storm season upon us, homeowners might want to think twice before removing fallen tree limbs. Although wood is not a good conductor of electricity, a wet tree could shock and harm anyone who comes in contact with it. Again, notice the linemen are using rubber gloves and sleeves for their protection, also the insulated stick. So in this demonstration, we have to put this up on that box, because if we put that tree on the ground and lean it up against the power line, we could get hurt just by standing next to that tree. So the danger here is the person on the ground touching the tree. So what he's going to do, he's going to lean this tree up against 7,000 volts. So if you ever see a tree near your house on the lines, don't touch it. Trailer hot? Right now, if he left it there, 7,000 volts would be going down feeding the ground. We can't do that because we destroy our equipment. Right now we don't have a fuse in there. It'd probably blow up our generator. He has to pull it away. And that's electricity trying to stay that path to ground. It's trying to find ground. That's why it's drawing an arc. That's like a lightning bolt. Next we have an aluminum ladder. Aluminum ladder is very conductive. Anyone who paints or does home improvements should look up before they go up. Placing a ladder on a hot conductor could result in a fatality. 10 feet of clearance must be maintained at all times near our wires. Again, in this demonstration, the danger is not the guy on the ladder. The danger is the guy that puts the ladder on the wire. Because the ladder can handle 7,000 volts. As long as we can keep feeding that ladder, it can handle it. Your heart can't handle it. So once you touch it, it goes through your body, in your hand, out your foot. It's going to go through your heart and kill you. Okay, trailer hot? Basically, look up before you go up. Pat, 1 second. I want everybody to look at the street light, Trailer Hot. That's the street light. This light represents a light in your house, okay? Because the primary comes down, our 7,000 volts goes through the transformer, goes down, goes into your house, 120 volts. This is basically your house. That's a light in your house right there. Watch when he draws an arc. You can watch the street light and you can watch the light in your house. Watch it dim. See it go out? When your lights go out, sometimes that might mean a tree went on a power line somewhere. And basically our power supply, our substation is trying to feed it. And sooner or later something's going to trip or something's going to fail. Either wire burns open or we have a circuit breaker back at the station that blows because I can't handle the load. Telephone and cable wires may become wrapped around our conductors in storms. These wires may look insulated, but they will not protect you from our primary voltages. Do not become a path to ground. Again, maintain a minimum of 10 feet of clearance near down wires. Notice the arc that is made when the cable TV wires comes in contact with 7,000 volts to a grounded fence. So basically in this demonstration, we're going to show you a cable TV wire that gets wrapped around our primary because of whatever reason, a storm or a car hits a pole and it gets wrapped. We're going to show you that you don't touch this. Even though it's cable TV wire or phone wire, it can be a conductor of electricity. It could have 7,000 volts in it. It looks insulated, but it's really not rated for it. If you touch it, you would die. Trailer Hot? So what to get from this demonstration is you see any power lines down, cable TV wires down, phone lines down, give us a call. We'll take care of it. That's a cable TV wire. Now, if Pat, one second, Pat, if Pat left that on there long enough, something has to fail because we're basically feeding electricity to ground. Most likely that wire would burn open. That's why you have circuit breakers in your house. The circuit breaker has to be weaker than the wire in your walls. If you put like a 50 amp breaker to a 12-2 wire, that 12-2 wire might burn open before that breaker ever trips. That's why the breakers are designed to fail. Right now, we don't have a breaker up there. All solid blades. We didn't put a fuse up there. One thing, it scares you. So, for this demonstration, we only do it real quick because we don't want to damage any of our equipment. We don't have a fuse up there. Go ahead, Trailer Hot. In this next demonstration, we'll show how a wet fire hose will conduct electricity. Over 7,000 volts will travel down this hose to complete our circuit. While fighting fires, firemen should be aware of energized conductors at all times for their safety. Basically, there's a fire hose right here. All we did is cut a little piece out of it, put a connector on both ends, and we're going to show you that we're not going to have a solid blade up there. We're going to put a fire hose up there, and we're going to close it to complete our circuit through this hose. Well, what does that mean to you? What that means to you is if you're near an accident and you see firemen fighting a fire and a power line comes down and it comes down on that hose, even though it's not metallic, right, it will conduct electricity. And if you touch it, even though you're 200 feet away, you could get a shock or become electrocuted. So in this demonstration, if everybody would please look at either the light on the pole or the little light on the trailer that represents the light in your house, he'll complete the circuit. Trailer Hot. And we could use a rope here. We could use many things, but we're just trying to show you a fire hose. Now watch the light on the pole, the street light. It should light up. See that? 7,000 volts is going through that hose, just like I talked about. If somebody was fighting a fire and that's out 100 feet, 200 feet, 300 feet, and a power line comes down on it, the guy holding on to it is going to be injured. Next I'd like to talk about is generators. Due to the number of storms that may cause outages, more and more people are buying generators. Generators not hooked up correctly are very dangerous to linemen, firemen, and anyone else near down conductors. As you saw during our demonstration, a 120-volt generator can backfeed a line to over 7,000 volts. So for the safety of linemen and the public, please turn off your main breaker when you're using a generator. So basically, we got this generator from Home Depot, okay? So we plug it into the house. What we're gonna show you, if you do not disconnect your main breaker, your little generator, you see where that meter is? It's gonna go through your house, it's gonna go up that weatherhead, it's gonna go to our lines through the transformer, and it's gonna be 7,000 volts on our end, just by your little generator that you want to keep your refrigerator going. So it's very important that you disconnect your main switch when you backfeed with your generator. The switch on the generator. Switch. The generator switch. So basically, if you see right now, just by turning on your generator at your house, of course your lights come on. That's what you wanted. But what you didn't know is now you just lit up the street light on the pole. And also what you don't know, it goes through that tub right there with the number 3 on it. 120 volts goes up that leg, comes out the top. Now there's 7,000 volts on the top because of your generator. He has a tester up there testing it, Pat. 7,000 volts right there, all because of your generator. So what that means to us in a storm, when we come upon the down wire, we think it's safe, somebody plugs in their generator, you could backfeed that line. Now we have 7,000 volts at our feet. We already showed you how dangerous that is. So please turn your main breaker off when backfeeding with a generator. Due to fatigue, drunk drivers, and cell phones, we have a large number of hit poles. If our wires end up on your car, we recommend that you stay in your car until help arrives. If your car becomes a hazard due to fire, smoke, or any unknown situations, you should exit your car by jumping. Okay, basically what we're going to do in this demonstration is we're going to energize this car with 7,620 volts. Now, if a wire's on your car and your car is hot with 7,620 volts, again, stay in the car, but if you have to leave because of a fire or smoke, jump out of your car. You would stay in the car, open the door, jump clear of the car, and just go baby steps away from the car, okay, till you're in the clear. Now, this is where you might forget, well, I left my baby or I got my pocketbook with $1,000 in there, I'm gonna go back and get it. This is where you die. You come back, you're staying on the ground, you touch the car to get to your pocketbook with $1,000 in it, and you can't spend your $1,000 because you're dead. Because what you have to do is jump out of the car and stay clear of it. If you have a valuable in there, you must bring it with you or throw it out, okay? Trailer hot? So right now, this car is going to be energized with 7,000 volts. And he's going to touch it with the glove and the hot dog in it, again, acting as your finger. Trailer hot? Now right now the glove has the rubber tires and it's on insulated mats. So that's how it protects us. Because if it didn't have that, we wouldn't step near it. Because electricity is going to go into the ground and it's going to seep out. And we could become electrocuted, believe it or not, just by stepping like this. So basically, we showed that demonstration real quick without a fuse in there. Now this is reality. The fuse in the other one, Glenn? In the riser? Put the fuse in that one. What Glenn's doing is he's going to put a fuse up in our circuit so that we minimize the outage when somebody hits a pole, because we don't want everybody to go out. We want just a few people to go out. Trailer hot? So basically right now somebody hit the pole and the wire comes down on your car, and then the wire goes off the car to the ground. And this is what happens. Again, your lights are out, now you'd call us. These guys aren't actors, this is what we do. This is a lot of fun. Thank you very much.
Beautiful.